Okay, 6.2.2, we want to list and completely factor all the polynomials of the form x to the fifth plus ax squared plus bx plus c over z2. So I went ahead and wrote them out and then listed them out. So a, b, and c can either be 0 or 1, and then we get these numbers here, or these polynomials here. So I thought the easiest way to do this would be to first just factor the ones that were obvious, like this one. Like take out an x from it, and you x to the fourth plus x. And then if you look up from our last problem, 6.2.1, we can see that x to the fourth plus 1 is right here. Well, wait a minute. Sorry, other way around. If you look here, this is x to the fourth plus 1, and then we can see that's here. So from there, we can just, oh wait. Mess this up. Yeah, I should have put a 1 here. Okay, x to the fourth plus 1. Then we know that is, what is it? X plus 1 to the fourth power. Okay, so all of these you can do that way. Let's do another one. So this one right here, x to the fifth plus x squared, take out an x to the fifth plus x, and then let's take out another x, and then x to the third plus 1, and then x to the third plus 1. What is that? Well, that is going to be in this list here. X to the third plus 1. It's going to be this orange one here. So let's look for the orange one over here, and there we go. So that's just going to be x squared plus x plus 1. So that's going to be x squared plus x plus 1 multiplied by x plus 1. Okay, so if you can take out an x, then you just have to look above in the last problem to figure out what to do next. But if you can't do that, for example, let's look at this one right here. Right here, we're not able to take out an x, so we're left with our own devices. So let's try this real quick. And we'll just use some long division to solve it. So x to the fifth plus 1. Okay, so we'll try x plus 1 since we can't take out an x, so the next obvious thing would be to take out an x plus 1. So x to the fifth, x to the fourth, x to the third, x to the second, x to the first, and finally 1. So now long division, so x to the fourth, x to the fifth, x to the fourth. Add, and I'm gonna, to subtract, and I'm subtracting in Z2, so I'm subtracting an x to the fourth, which is gonna be negative x to the fourth, but negative 1 is actually positive 1 in Z2, so I'm just gonna put it x to the fourth here. Boom, boom, put a 1 here, and just keep going. So x to the third, x to the fourth, x to the third. Okay, so 0, x to the third. Remember in Z2, negative 1 is positive 1. All right, so 1, x to the second, x to the third, x to the second, 0, x to the second, 1, x to the second, and we get an x. And then finally a 1. So we get x plus 1, remainder 0. So we know it's factorable. We know that this factors into this here. So we can go ahead and write it out. X to the fourth plus x to the third plus x squared plus x plus 1. And then that's going to be multiplied by x plus 1. From there, we can go ahead and look to see if we can see this number in our what we've already done. So let's look. X to the fourth. I don't see it in there, so it's not prime. It looks like we can keep dividing it. So, oh, wait a minute. Am I saying this right? Oh, looks like I need to keep this one going. Wait a minute. X to the fourth plus. Oh no, I did it right. Okay, yes. So we're looking at this one here, and this one is prime because it's a gray one. This one's a gray one. So that one is x to the 4 plus x cubed plus x squared plus. Oh, it's right here. It's right there. Okay, so then we know it's prime, and we can't factor that one any further. We also know that we can't factor this one any further, so we're done there. Okay, so these are two techniques that you can use to solve it, and they will finish it. So the next thing I have to talk about is this problem, right? This last one that I found. And this one right here I found to be prime because I tried all of the I tried this one, I tried just the regular x, I tried this one, I tried this one, and this one, and it none of these divided into it. So that's the end, because if one of these x to the fourth divided into it, well then what we would have is some x to the first power, which we already know these did not divide into it. So we're done there. That one is prime. This one is prime. It's prime.